the lower layers have more gases and more molecules. The lower layers has more gases, the lower layers have more molecules. And the atmosphere becomes rarefied. The lower layers has more molecules, the lower layers has more gases, and the atmosphere becomes rarefied with height. It becomes rarefied with height. In the above layers, we have lesser molecules. So this is what I was trying to tell you, that say in the lower layers, there are 1000 molecules, or maybe say 10,000 molecules, of which nitrogen will be 7,800, oxygen will be 2,100, and they are very well mixed. Okay. You go higher up, you have got 1000 molecules. Nitrogen will be 780 molecules, and oxygen will be 210. Go higher up, the 100 molecules. The nitrogen will be 78 molecules, oxygen will be 21 molecules. Ratio same है. ऐसा नहीं है कि all heavy gases नीचे है and the nitrogens above. Okay, but you have more molecules lower height पे, you have got less molecules in the above height. We call this as density stratification. Why do we have this? Okay, why we have this is because of two reasons. Write down. This stratification is because of two reasons. Yeah, online, some of you missed me for some time because the problems in the camera there, we have again switched on. Okay? So I'm explaining the arrangement of the atmosphere. I'm explaining how the atmosphere is organized or structured. So ये layering का difference क्यों है? Because two reasons. One is atmosphere has weight, and atmosphere, number two is atmosphere is compressible. Atmosphere has weight is one reason, and the second reason is atmosphere is compressible. देखो, atmosphere gases हैं. Okay, there are gases. The gases, they are scattered like this. Okay, they are scattered here. Now, because atmosphere का weight है, because of weight, okay, the whole is heavy atmosphere. The lower parts will get compressed. Compressed का मतलब क्या है? The gases have come more closer together. Okay, so they are more packed up here. Okay, पहले आप सोचो कि you had say 100 molecules. Because of packing up, the lower layers probably have 50 of those. ऊपर में हल्का हो गया, इसका weight कम है. When this packs, you might have only 20 molecules. ये और हल्का हो गया. When this packs, it has only 5 molecules. ठीक है? So air has weight and air is compressible. Molecules are far apart, you can bring them together. No, water is not compressible. Water आप compress नहीं कर सकते. That's why we have all the principles of hydraulics, because water can't be compressed. But gases can be compressed. Solids again can't be compressed. They'll break if you compress solids. Okay? ये important एक principle है atmosphere का. The atmosphere has density stratification. The lower layers have more molecules and the above layers have less molecules. So if you look at the layering, you'll find that around 5 to 6 kilometers के height में, okay, you have 50% of the atmosphere. The whole atmosphere, I'm saying atmosphere कहाँ तक है? About 1000 kilometers तक है. Till 1000 kilometers, say the entire atmosphere say has, random number, say has, okay, 10,000 molecules. Because of compression, 5,000 are within 5-6 kilometers alone. Okay. Within, say, 12 or 13 kilometers, यहां पर you have 75% of the atmosphere. Okay, तो अगर 10,000 molecules हैं, okay, 5,000 are within 5-6 kilometer, 7,500 are within 12-13 kilometers height. By the time I hit say 28 to 30 kilometers, this is almost 90% of the atmosphere. It's almost 90% of the atmosphere. No, not 28, 16, sorry. By the time I hit 16 kilometers, it is 90% atmosphere. By the time I hit 28-30 kilometers, इसके अंदर में 99% of atmosphere is over. You all imagine these numbers, all of you here? Which means what? If I go beyond this, very less molecules. पूरा atmosphere अगर 10,000 है, okay, beyond this, you just have, okay, some rarefied atmosphere, not enough for breathing. That's why you go up, you start breathing problems happen because hota nahi enough oxygen. Okay, so remember these numbers more or less. 50% of atmosphere is within 5-6 kilometers. 75% atmosphere is within 12-13 kilometers. 90% is within 16 kilometers, 16 kilometers. And by 28-30 kilometers, okay, you have 99% of atmosphere is gone. इसकी beyond क्या ही बचता होगा? Imagine this. This 1% is left beyond 28-30 kilometers. Yes, Hemant. That's why you can have a stroke, you can have nose bleeding. Okay, the lungs can't pull in enough of oxygen. You can have problems of suffocation because the atmosphere is very rarefied at higher heights. ठीक है? Okay. So अगर इसको हम graphical देखें ना, if I see this graphical, मैं सुन लो पहले all of you. Say, okay, on this axis I am measuring pressure. Okay, and on this axis I am measuring, sorry, on this axis I am measuring height. On this axis I measure pressure. The weight of one atmosphere, okay, is at the sea level. See, you are at the sea level here. ये आपका sea level है, zero height. At sea level, you have the pressure of entire atmosphere. Sea level पूरा atmosphere का height है मेरे पास. So say, okay, this is 1 atmosphere pressure. So this is 2 atmosphere pressure. This is 3 atmosphere pressure. So at the sea level, कितना pressure हमारे पास है? 1 atmosphere. You go at a height of 5 to 6 kilometers. कितना खत्म हो गया? 50% gone. So at this height, how much pressure will I have now? 0.5. It will be 0.5 atmosphere pressure. If I rise to about, okay, 12-13 kilometers, how much pressure now? 0.25. 75% is gone, right? Okay, so you have 0.25 atmosphere pressure. You rise to a height of 16 kilometers. कितना बच जाएगा आपके पास? You have only 0.1 atmosphere. To draw the graph is something like this. I hope you understood the point here. At the sea level, you have 1 atmosphere pressure. You rise by 5-6 kilometers, 50 ओवर, ओनली 50 बचा हुआ है आपके पास। तो आधे एटमॉस्फेयर का प्रेशर आपके सर पे आ रहा है। You have a pressure of 0.5 atmosphere. You rise up to 12, 13, 75% gone. ऊपर कितना बचा आपका? 25%. You have the weight of only 25%. Okay. So atmosphere pressure will be about 0.25 atmosphere. And you rise till 16, it falls to 1 atmosphere. You have gases up to 1000 kilometers. You have gases up to 800 किलोमीटर. But imagine कितना कम molecules है अब वहां पर. That's the discussion point. Point 1 atmosphere, 0.25 atmosphere, 0.5 atmosphere, 1 atmosphere. Okay. So this is 5-6 kilometer, 12-13 kilometer, 16 kilometer. You join this, you get a graph something like this. Very, very. So by the time you go beyond this, you और कम हो जाएगा. It'll be 0.01 kilometer. By the time I hit, okay, 30 kilometers, 99% is gone. Okay? So it is almost an exponential decline in the pressure and the atmospheric mass to height. ये ग्राफ समझ में आ रहा है all of you here? By the way, 1 atmosphere pressure का कितना वैल्यू है पता है आपको? We write this as 76 centimeters of mercury column. It's approximately 1013 millibar pressure. ये अलग अलग यूनिट है. 1 atmosphere का मतलब होता है 76 centimeters of mercury column, or we also write this as 1013 millibar on average at the sea level. At the sea level. Yes, 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 correct. Yeah, good afternoon. You joined now. कोई बात नहीं. It's never late to start a good thing. No problem. Anybody else here? The atmosphere arrangement का दो part है. One part is that there is variations in degree of mixing. The lower layers are more mixed, atmosphere. The above layers, we have more segregation of the gases and ions. The second part is, even if the molecules for much of atmosphere are not separating out in terms of their weight, there is density layers of atmosphere. The lower layers have more packing, more molecules, more density. You rise up, the gases are more far apart, and the atmosphere is more and more rarefied. Okay. Now you come to the third type of atmospheric structuring, which is the temperature layers of atmosphere. The pattern of a heating and cooling of the atmosphere. The temperature layers of atmosphere, or the temperature patterns of atmosphere, and the pattern of how atmosphere cools or heats up, okay, through height. This is the most common structure you all have studied. ठीक है? So before you write anything down, some of you know this. For others' benefits, let me explain something first. Think of analogy. Analogy is, say, this is the government. Directly, indirectly, the government feeds us. Okay. For some, the government gives food directly. Okay. Midday meal scheme, the government giving the food. Food for work program, government gives food for whatever work you do. For others, the government makes you work, you earn money and then you buy the food. ठीक है? So अगर ये government है and these are people. Some people, they get food directly. In some cases, the government gives money to some system, some institution, you work for them and they will pay you money and then you buy your food. Right? An analogy of how a society is managing itself. I say in one case, the government directly खाना दे देता है आपको. Other case में government पैसा देता है कोई agency को या फिर कोई institution को. So I'm a government employee. I work for that company and the company pays me. So it's not directly food from the government. तो वैसे ही Earth में भी the same thing happens. There is sun. The sun is radiating energy. In some parts, the energy is directly absorbed from the sun. In other parts, the energy comes, it hits the land, it hits the water, and when the land and water releases heat, then the gases are heated. It's like, say I have some object. I throw it to you. One is you can directly catch it. But say I throw it very, very hard and a small boy can't catch. What happens is his father catches the ball and gives it to him. So sometimes energy is so powerful hota hai that the gases here they can't catch. The energy hits the Earth's surface, the surface becomes hot and the surface releases, then the gas can catch it. So some amount of heating, this is direct heating. And some amount of heating is indirect heating. Direct heating hoga, these layers will become hot as sun is getting trapped. In this case, say this is one particle which cannot catch the Earth's energy. Energy goes straight, the surface captures and then this body will capture. So this body heating is not same as this body is heating. This body heating is more when it is more near the surface. This body heating is more when it is more away from surface. So some layers of atmosphere are heated from above and some layers are heated from below. Atmosphere has both the process operating. Is it okay all of you here? Okay. And if some layer, imagine these are layers. If some layer is heated from above, इसमें warm air कहाँ होगा? ऊपर होगा कि नीचे होगा? If a layer is heated from above, the warm air will be above. So this is hot, this is warm, this is cold. If the layer is heated from below, in that case, this will be warm, or rather, I'll say this will be hot, this is warm, and this is cold. In some layers, it becomes cold with height. In some layers, it becomes warm with height. It depends on how is the layer being heated. If heated from above, warm air is above. As you go down, it becomes cold. If heated from the ground, then the lower airs are warmer. As they rise up, it becomes cooler. Simple analogies. You know this mountain, right? Mountains are cooler, right? Okay. Which part of earth is near the sun? Is a mountain top? Is a mountain floor? अगर sun यहाँ पर है, तो sun के पास कौन सा वाला area है? The top or the floor? The top. Then which should have been hotter? The top. But we know, even if top is near the sun, the top is not warm. Why? Because the top is not directly absorbing the solar energy. Energy goes straight, hits the surface, warms the surface, and while it is releasing heat, okay, this becomes more warm and this becomes relatively cooler. So even if the mountain tops are near the sun, they are not warmer than the surface at the sea level. I think most of us know this. I'm just putting that in one discussion perspective. There are two lines here. Likho. Yes. These topics are the most commonly studied topics, and maybe some nuances might help you, otherwise nothing extraordinary here. Write down. Point number 1. The main source of all energy is the sun. The main source of all energy is the sun. 1. Number 2. The Earth atmosphere system receives solar energy. The Earth atmosphere system receives solar energy in the form of radiations. Okay. For some of you, I may have mentioned this already. For others, radiation, we call this as the solar radiation spectrum. We have gamma rays, we have X-rays, we have ultraviolet rays, we have the visible spectrum, we have infrared, we have microwaves, and we have radio waves. This is the spectrum of the solar radiation. Gamma rays, X-rays, this is ultraviolet radiations, this is the visible spectrum, okay, from violet to red. So, beyond violet it is ultraviolet, beyond red it is infrared. Okay, so iska jo wavelength hai, is approximately 0.4 microns. Iska jo wavelength hai, 0.7 microns. Wavelength is the length between two crest or two trough. अगर ऐसे radiations हैं, ये crest है, इनके बीच में जो distance is called as the wavelength. So as I'm moving from gamma towards radio wave, the wavelength is increasing. This is short radiation, these are long radiations. Okay? So some basics I presume you know, otherwise liख लो और क्या, no issues. Yes. So as I move towards this is short wave. Okay, these are more powerful. These are long waves. This is less powerful. Okay, so these are long wave radiations. These are short wave radiations. Short wave ones are more powerful. Long waves are less powerful. Okay, so this very elementary thing you remember. Yes, Hemant, we'll come to that eventually. Okay. You take all of you. The energy which enters atmosphere is this, and this. These two, they don't enter atmosphere. कहाँ चले जाते हैं? They're absorbed by Earth's magnetosphere. Add करो. In your notes it said gamma rays and X-rays are largely absorbed and they are deflected by Earth's magnetosphere. The gamma rays and the X-rays are largely absorbed or deflected by Earth's magnetosphere. This is approximately the height of 60,000 kilometers above Earth's surface. तो अर्थ के अंदर में ये नहीं आता, ये आएगा तो it destroys Earth completely, खत्म हो जाएगा. What enters atmosphere is largely ultraviolet, visible and infrared. Head down. Ultraviolet, visible spectrum and infrared are the main radiations that enter Earth's atmosphere. Ultraviolet, visible spectrum and infrared are the main radiations which enter Earth's atmosphere. And again a fact, इन तीनों में maximum कौन सा होता है? Which is maximum? Infrared. It's maximum and it goes more distance. Ultraviolet, okay, doesn't enter the lower parts. Just know this factual thing. The infrared makes up almost 50% of radiations entering the atmosphere. 49 point something hota hai. Infrared makes up about 50% of the solar radiations entering the atmosphere. ये वाला पार्ट जो है ना, the most popular question in your prelims. हर साल कुछ ना कुछ यहाँ छेड़ देगा. Some radiation value, some percentage, they keep asking. Okay. Most make a mistake कि they end up marking this as more. ये कम है, ये maximum है, a bit less and a bit less. I think ultraviolet is about 6, 7, 8% hota hai. 49 point something is infrared, the rest is all visible spectrum. Okay, just have an idea about that. देखा आपने? The next point लिखो, right next. The ultraviolet radiations are largely absorbed in the higher atmosphere. They're absorbed in the higher atmosphere and in the stratospheric ozone layer. They're absorbed in the higher atmosphere and in the stratospheric ozone layer. I'm sure you know these words. Stratospheric ozone layers. Next, infrared is absorbed across atmospheric layers, but more in the lower atmosphere. Is absorbed across atmospheric layers, but more in the lower atmosphere with moisture. Okay, जहां पे water vapor है, water vapor can absorb infrared. Okay, continue. Okay, infrared also gets absorbed by the Earth's surface. Infrared also gets absorbed by the Earth's surface. And third, the visible spectrum The visible spectrum is not absorbed by the atmosphere. The visible spectrum is not absorbed by the atmosphere. It is absorbed only by the Earth's surface. It is absorbed only by the Earth's surface. तो अगर एटमॉस्फेयर देखोगे आप, देखिए, the sun's ray is coming. Some amount of energy is absorbed here, absorbed here, absorbed here, absorbed here. Bulk of energy comes absorbed here, bulk of it absorbed here, and also absorbed by the Earth's surface. And lot of energy passes straight and absorbed only by the Earth's surface. So this is the visible spectrum. ये पूरा surface में आ जाता है. Okay, this is 0.4 to 0.7 microns. ये surface hit करता है, and then it starts heating the layer of atmosphere from below. This is IR. IR थोड़ा बहुत होता होगा, but much of IR comes down, and the lower, because water vapor ज़्यादा है near Earth's surface. So lower layers में IR gets absorbed. It also gets absorbed by the Earth's surface, IR. And this is the rest of ultraviolet. The maximum absorption for ultraviolet is in a zone which has ओजोन गैसेस. तो एटमॉस्फेयर देखोगे अगर, some atmosphere is heated from above, but not much. Much of atmosphere is heated from below. You know? Therefore, while some layers of atmosphere are heated from above, some layers of atmosphere is heated from above, the bulk of the atmosphere is heated from below. The bulk of atmosphere heated from below. Is it okay, all of you here? So what I have is one layer of atmosphere which is warm below, less warm, cold, very cold, and very, very cold. Some layer of atmosphere, it is warm, less warm, and cool. And some layer which is warm, less warm, and it is cool. So इस layer में, okay, this is heating from above. This also is heating from above, and this is heating from below. This layer has the layer of ions. Okay. This is the layer of ozone gas. And this is the lowermost atmosphere. Ions, because energy coming in, some gases split and the ions have absorbed the heat. Okay. इसमें यहाँ पर ozone है. Ozone can absorb at constant size. The ozone layer, this absorbs ultraviolet. And this layer is absorbing, okay, infrared and absorbing the out radiations from Earth's surface. Is it okay? Layers heated from above, upper warm, cool. Again from above, warm and cool. From below, warmest, less warm. I give a more range here. यहाँ पे क्या हो रहा है? यहाँ पर this area has no ions. It also has no ozone. So there is no absorption from above. So this is not heated by the incoming radiations. This I wrote. Okay. ये lower most atmosphere है. Okay. This is heated mostly by IR, infrared, and heated, okay, because of out radiations from Earth's surface. ये इसकी heating कैसे होता है? The lower part has moisture, IR absorb कर लिया. Plus some energy has got absorbed and it is re-radiating. So lower layers are warmer and the above layers are relatively less warm. So this is largely heated by IR in the lower layers and by out radiations from the Earth's surface. Again, watch here. As energy comes in, the above layers absorb first. That's how they become warm. Lower layer आते आते that component of radiation less हो जाता है. यहाँ पर कम absorb हो रहा है, तो और कम absorb हो रहा है. So the above parts, they receive the bulk of the energy. That's why they are warm. It's like, I am throwing some things. The people in the first row will catch more. Less is left for the rows behind. The energy आ रहा है. This layer catches more. Okay. When I come down, less energy remains for this to catch. That's why this is warm, less warm, this is coolest. वैसे energy इधर भी आ रहा है. Okay. This layer, okay, catches more of radiations. By the time you come here, यहाँ पर कम बच जाता है. Same analogy. I'm throwing some say books or I'm throwing some articles. The people in the front rows will catch more. Okay. By the time I hit the next rows, amount of substance becomes less. Okay. So यहाँ पर the heating is from above. यहाँ पर heating is from below and so on. अच्छा. यहाँ पर heating हो रहा है कि नहीं हो रहा है? In this layer, do we have heating or not? आगे heating नहीं हो रहा का मतलब क्या है? तो पूरा cold हो जाएगा, right? Then it is cold. सब हर जगह cold है. I'm asking, is this layer getting heated or not? It is not getting heated from the incoming radiations. तो ये वाला layer warm नहीं होगा. But ये layer warm है ना? So won't this layer warm will make this layer warm? Okay. इसके ऊपर जाओगे less warm. इसके ऊपर जाओगे a bit more cooler. इसके ऊपर जाओगे a bit more cooler. तो ऐसा नहीं है कि ये layer heat नहीं हो रहा है. Our point is ये layer ऊपर से heat नहीं हो रहा है. But the heat source is from below. Is it okay, all of you here? Every layer gets heated. Okay. But they will get heated from different source points. यहाँ पर source point ऊपर है. So warm, it becomes relatively cooler. इसमें भी source points ऊपर है. Okay. Warm and relatively cooler. इसमें source point कहाँ है? Surface पे है. So warm and relatively cooler. इस layer के लिए the source point is the above part of the stratosphere. ये warm air है ना? This warm will make this air warm. This warm will make this a bit less warm. This less warm will make this even less warm. That's why you rise up, it becomes relatively cooler. Take all of you here. So in this, if now I am plotting temperature, okay, sorry. On this, now I plot temperature. This layer, this layer, this and this. So on this side, ये temperature. Okay, 0 temperature, 10 temperature, 20 temperature, 30 temperature, and so on. ये बढ़ेगा इधर. In this layer, the lower layer is more warm. You rise up, it becomes cooler. In this layer, the above layers are more warm. You go down, it becomes cooler. In this layer, the above layers are warm. You go down, it will be cooler. In this layer, this warm makes this more warmer. Rise up, it becomes less cool. Is this graph understood, all of you here? Third layer का source कहां से है? Third layer का source is the second layer का top. ये तो warm हो गया ना? So this warm air will also make this warm. हाँ? दोनों होगा, but it's more of conduction. इतना कम यहां पर molecules है कि घूमने लायक बचा नहीं. That's why more in contact is a bit more warmer, less contact less warm. But ये तीनों हर जगह काम कर रहा है. Conduction भी है, convection भी है, radiations भी. Third layer from above. No, third layer is from below. That's why. Okay. So on this graph, if you move on your right, it is more warm. Okay. Towards left, it is more cooler. This warm, it becomes cool with height. This warm, it becomes cool with height. This is warm here, it becomes cool as I go down. This is warm, it cools as I go down. So ये जो line है, zigzag pattern, ये beautification के लिए नहीं है. Okay. ये zigzag बना दिया. There is a scientific principle how it is. I remember one guy in the class, उसको zigzag बनाना था, ठीक है? वो बोला zigzag ही बनाना है, इतना सर दर्द क्या करना है? ऐसे 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 बना दिया, हो गया. Okay, there's not any random zigzag. Okay, this means what? This means what? Fall in temperature with height. This is increase of temperature with height. This is again fall. This again increase. तो ये जो names है हमारे, okay, troposphere, stratosphere, mesosphere, thermosphere, ये इस pattern पे based है. Yes. पार्ट है. हाँ. सर जो ओजोन लेयर का जो अपर पार्ट है, सर कौन सा ज्यादा? You tell me. Which has more heat, more ozone? But यहां पर बहुत कम ions हैं. ठीक है, total heat यहां बहुत कम होगा. So this will be more warmer than this one. तो यहां पर ज्यादा मास है ना. ठीक है, आपने गैस चूल्हा पे दोनों हाई फ्लेम किया है. एक में कम पानी है या फिर छोटा आयरन रॉड, एक में is a dense one. Dense one can absorb more heat, right? As idea. If you know the formula mc theta, mass is the important part of heat. जितना ज्यादा मास होगा उतना ज्यादा हीट अब्सॉर्ब कर रहा है. Okay, so the layering we call as troposphere stratosphere is this layering. The lowermost layer is called as the troposphere. This is called as the stratosphere. Then we have the mesosphere. Then we have the thermosphere. So layering क्या है? So these layers I know you know. Okay. The problem is the mechanism some of us keep on missing out. This is called as the troposphere. This is the stratosphere. ये names के भी meaning है, but we will not enter that domain right now. And this is called as thermosphere. Stratosphere में it is cooling with height. Stratosphere में warming with height. Mesosphere again cooling with height. And thermosphere is again warming with height. ठीक है? Whether you have geography or not, 90% of climatology is your GS course. ठीक है? In optional, you have more time to understand the nuances. Otherwise, रट्टा मारते रहना और क्या? Wait for the Sanjay Shri. Those details will come. ये समझ में आया कि नहीं pattern all of you? What I want is, आप ये diagram बनाओ and write down 3 points here. One is troposphere में क्या? Troposphere is heated from below. It is heated by IR, infrared, and heated by out radiations and loss of heat from Earth's surface. Okay. Troposphere is what? Troposphere is heated from below. It's heated by IR and out radiations plus loss of heat from Earth's surface. Loss of heat from Earth's surface. And troposphere is the weather layer. It is the weather layer. सारे weather phenomena यही होते हैं. It is the weather layer. All winds, all temperature patterns, all cyclones, all rainfall, all clouds. Okay. Everything happens in the troposphere. ठीक है. इसमें एक और पॉइंट. Okay. ये आप समझेंगे बाद में, बट अभी लिख लो आप. It is the weather layer because it cools with height. It is weather layer because it cools with height. It allows for vertical movements of air. It allows for vertical movement of air. ये important conceptual point है. ये weather layer है क्यों? ठीक है? It's a weather layer because it cools with height, and is cooling with height helps the air to rise. Now imagine this. Say if I have air, all of you watch here. Say I have air at say random 40 degrees centigrade. इसके ऊपर में there is 20 degrees centigrade. एक और केस, there's 40 degrees centigrade. इसके ऊपर में there is 60 degrees centigrade. Case A and case B. Which air will rise? समझ में आ रहा है यहाँ पर? Because this is warm, this is relatively cooler. Warm will expand हल्का हो जाएगा, it will rise. But अगर ये इससे cool है, ये expand नहीं करेगा. ठीक है? So as I go above, hot, warm, less warm, cool, very cool. ये जो trend है, This forces air to rise. और ये air rise करेगा. Rising air will create clouds. Okay. It rises. यहाँ पर खाली हो गया. So air will move in. This becomes winds. So because air is cooling with height, that is why we have all the weather patterns. The word tropo means turning, mixing. The troposphere का मतलब है it is the weather layer. This was a question in your prelims. No, sorry, in your GS mains. Why is troposphere the weather layer? ठीक है? So if I am answering now, लिखो. Why is troposphere the weather layer? Number 1 क्या लिखोगे आप? Because it cools with height and it allows air to rise. It cools with height and allows air to rise. और क्या लिखोगे बताओ? It's like मैंने आपको पूछा. Is different depth of understanding. I ask you, how have you become an IAS officer? Answer is, I cleared the examination. Good. Next point, I got good marks. Next point, because I worked hard. ये सब लिंक ही है ना आपका. So why is the weather layer? Because it cools with height. Okay. It allows air to rise. Why this happens? Because it is heated from below. Because it is heated from below. Why from below? Because it is heated by IR absorbed by water vapor at lower layers. Is heated by IR absorbed by water vapor in the lower layers and by loss of heat from Earth's surface. And because of loss of heat from the Earth's surface. Is my all of you here? अच्छा. अब ये जो loss of heat from Earth's surface है, okay, this should go on like this. यहां पर change होता है ना, cool, suddenly becomes now warm. ये जो transition layer है, this acts like a lid. It won't allow the air to come out here. यहां तक it's cooling, it's cooling. यहां से reverse happens. तो यहां के बाद में क्या होगा? Will the air escape here? No. The air gets trapped here. ये जो layer है, this is like the lid of the troposphere. इसका नाम क्या है? Tropopause. Called as the tropopause. एक और reason है आपका? The weather patterns are trapped within troposphere because of tropopause. The weather patterns are trapped within the troposphere by the tropopause. Tropo means what? Mixing. Pause means what? रुक गया. The mixing has stopped. Okay. The troposphere has a lid. Okay. The lid traps all the weather patterns inside the troposphere. It's called as tropopause. वहीं ऐड करो. Tropopause is where atmosphere starts warming with height. Is where the atmosphere starts warming with height. So this is cold with height. अब क्या हो गया ये? Warm with height. What was cooling now becomes warm. What was cooling now reverses. इसको क्या बोलते हैं? Inversion बोलते हैं. Okay. The rate of cooling has now inverted. Tropopause is the inversion layer. Tropopause is the inversion layer. कहीं पर भी inversion होगा ना, वहां पर air और ऊपर नहीं जा पाएगा. This is a rule. You must have heard about this, right? Why do winters have more pollution? One reason is, in the winter, Delhi has air inversion. The lower air, okay, becomes cold, the above air is warmer. Okay, so the vertical rise can't happen anymore. The pollutants get trapped. So remember this phenomena. Any inversion का मतलब है वहां रुक जाएगा. Okay, so within bracket mention, any inversion layer will block upward movement of air. Will block upward movement of air. I hope कुछ समझ में आ रहा है आप लोगों को, right? कि these are terms I trust again आपने सुना है. Troposphere क्या है, stratosphere क्या है. But the nuances is what I'm trying to explain to you. Because the questions are asked more on these nuances. Okay, exactly. And as I teach more, you'll know a bit more details also. ठीक है? अच्छा, now this rate of cooling, ये जो cool हुआ है इसको क्या बोलते हैं? Next point. The rate of cooling with height in troposphere is called as, the rate of cooling with height in the troposphere is called as what? Normal lapse rate, which is 6.4 centigrade per kilometer. NLR बोलते हैं. It's called as normal lapse rate, 6.4 centigrade per kilometer. Take all of you done? So explained. Okay. Troposphere deal बता दिया मैंने. Okay. So some pointers here and some details here. In the stratosphere, write down. Diagram में लिख लो. जगह नहीं है तो ठीक है. Stratosphere is heated from above. The stratosphere is heated from above. The entire stratosphere is an inversion layer. The entire stratosphere is an inversion layer. The example of what we call as upper air inversion. Inversion of what? Inversion of the trend of troposphere. This is normal. ये होना चाहिए, but ये उल्टा हो गया. In inversion layer, will the air rise? No. Air will settle down here. जो settle होता है ना, वो layer बन जाता है. That's why it's called as stratosphere. Strata means what? Layer. Will a mixing air have layers? वो पूरा मिल गया. When air doesn't rise up, it settles down, it's called as stratosphere. This is an inversion layer. There is no vertical mixing. There is no vertical mixing in the stratosphere. It is heated by ultraviolet radiations. It is heated by ultraviolet radiations. That is trapped by ozone layer. That is trapped by the ozone layer in the stratosphere. Ozone is O3, 3 atoms of oxygen together. So give a subheading, something about the ozone layer. Subheading about the ozone layer. ओजोन किस लेयर में मिलता है जनरली? क्या हाइट है बताओ? Ozone is found from 10-15 kilometers up to 50 kilometers. 10-15 kilometers up to 50 kilometers. तो ये पूरे लेयर में ओजोन है। ओके, फ्रॉम अबाउट 10-15 से लेकर दिस हाइट इज अबाउट 50 किलोमीटर, ये ओजोन लेयर है। नेक्स्ट पॉइंट, ओजोन कंसंट्रेशन इज मैक्सिमम, ओजोन कंसंट्रेशन इज मैक्सिमम कौन सी हाइट में? एट अराउंड 20-30 किलोमीटर हाइट, एट अराउंड 20-30 किलोमीटर हाइट। ये पूरे लेयर में ओजोन है, बट मोर ओजोन इन दिस हाइट हियर। ठीक है, नेक्स्ट पॉइंट, ओजोन is continuously produced and destroyed in the atmosphere. It is continuously produced and destroyed in the atmosphere. एक साइकिल है, anybody knows the name of cycle? क्या बोलते हैं इसको? Called as what cycle? Ozone cycle, but what cycle? It's called as Chapman cycle. Chapman. It's continuously formed and destroyed. Again formed, again destroyed. ठीक है, चैपमैन, Chapman, चैपमैन साइकिल। ओजोन बनता क्यों है? हाउ इज ओजोन फॉर्म्ड? आई हैव ऑक्सीजन, ऑक्सीजन में अगर शॉर्ट वेव रेडिएशन अल्ट्रावायलेट होगा, इट विल ब्रेक इनटू ऑक्सीजन एंड ऑक्सीजन लाइक दिस, अलग अलग हो जाएगा। देन दिस वन विल गेट एडेड विद दिस, it gives us O3, again O3, because of short wave radiations it again will break into O2 plus O, then this O again will combine with another O2, again forms ozone, and this goes on. This process of creation destruction एक cycle है, it's called as the Chapman cycle. ये सब के लिए हमें ये चाहिए, that's why I'm saying it's absorbing to break up. अर्थ में where do we receive maximum radiations? On which latitudes? Which latitude receives maximum radiations? Low latitudes, right? Within 40 latitudes. Poles में कम radiations होता है, right? So if the low latitude receive more energy, ozone भी वहीं ज्यादा बनेगा, right? Head down. Ozone creation is maximum in the low latitudes and within tropics. It's maximum in the low latitudes and in the tropics. I need energy. I need radiations coming in. So ozone creation maximum कहाँ है? Low latitudes में. Minimum कहाँ होगा? High latitude near the poles. So where will we have more ozone? Tropics or at the poles? यहां पर एक slip है. Although ozone is created more at the tropics, ozone is found more in the poles. Poles have more concentration of ozone. Add करो. ठीक है? Ozone is created more in the tropics, but ozone concentrations are more at the poles. Concentration is more at the poles. तो ठीक है, you can know this. जो ओजोन का कंसंट्रेशन होता है, ओजोन concentration is measured in terms of what's called as Dobson unit. It measured in terms of Dobson unit. Okay. Tropics they have around 200 to 50 Dobson units. Mid latitudes they also have around 250, maybe 300 Dobson units. जो poles होते हैं यहां पर they can have more than 500 Dobson units. Tropics, they create more, but more ozone is found in the polar areas. ठीक है, इसका रीजन क्या है? What happens is, at the tropics, there is more destruction also. बन भी रहा है, मर भी रहे हैं. Right? High death rate, high birth rate. There's also more destruction. At the tropics, there is more water vapor. Water vapor will give us what's called as hydroxyl ions. Plus, tropics may you also have more amount of NOx, nitrogen oxide compounds. Okay? These two can destroy ozone. At tropics, you have got more hydroxyl ions and you also have more NOx compounds, nitrogen oxide compound, NOx बोलते हैं. These two are ozone depletion. Okay. From tropics to poles, in stratosphere, there are special winds. They're called as Dobson winds. Dobson winds. Most books write these as stratospheric winds. Tropics में ओजोन कम क्यों है? I said number one, at the tropics there is more destruction because tropics has more hydroxyl ions from water. Warm है, evaporation हो रहा है. Tropics have more NOx compounds, which again can destroy ozone. और एक stratosphere में special wind चलती है. Okay, the wind is from tropics towards the poles. तो poles में वो ozone लेके इकट्ठा कर देती है. We call that as Dobson winds. Dobson winds, somebody who discovered it. Okay, otherwise called as stratospheric winds. एक और point. At the poles, because it is cold and high pressure, ozone depletes less. Cold conditions में ozone will not deplete or will deplete less. ठीक है? All done, all of you here? Why is ozone more at the Antarctic and at the Arctic regions, less at the tropical areas? My next question to you is, आपने ozone hole सुना है ना? Ozone hole बड़ा कहां पर है? Where is ozone hole bigger? On which latitudes? At the poles. Which poles? Again Antarctica. Now this is a contradiction, right? Okay. Zyada ozone is found in the Antarctica poles and we are saying ozone hole bhi wahan zyada hai. The reason hai, okay, because of this tropics towards poles winds, the ozone depleting pollutants, they also go towards the poles more. समझ में आ रहा है यहाँ पर? Whatever you are producing as ozone depletion substances, ODS बोलते हैं. Okay. So अगर there was no human interference, then Antarctica would have had more ozone. But because the human factors and more people live in the tropical, subtropical areas, you're polluting more. Okay, you are creating ozone depletion substances more. The winds carry those also towards Antarctica and it starts destroying it there. At a point, the ozone hole is more pronounced near Antarctica. It's pronounced near Antarctica because the stratospheric winds, they carry ozone depletion substances. They carry ozone depletion substances towards Antarctica more efficiently. They carry ozone depleting substances, ODS, towards Antarctica more efficiently. इसका reason है because Antarctica is more cold. More cold, so you'll have stronger pull of the winds towards Antarctica. These can be questions. Okay, why do we have the ozone hole? अच्छा, by the way, एक चीज याद रहे, ozone hole ऐसा कोई hole है नहीं. It's basically the ozone concentrations are less. जैसे I'm expecting 500 DU. Because of depletion, it has now become 200 DU. That's why. It's not that it's a hole. It's not a gaping hole. Okay. Hole का मतलब ये है basically in that area the concentration of ozone has declined. Ozone अपने आप में बहुत कम है. If you add up all the ozone together and make a layer around Earth, the layer will be less than 3 mm thick. इतना कम ozone है, just 3 mm thick. Some places the concentration becomes even lesser. Put a star mark and write down. The ozone hole essentially is lower than average ozone concentration. Is lower than average ozone concentration. Around Antarctica, ozone concentration should be around 500 DU. Should be around 500 DU. But it reduces to less than 250 DU. It reduces to less than 250 DU. Dobson units. Average atmosphere का ozone thickness is 300 DU. The average of, okay, write down. The average ozone concentration for atmosphere is 300 DU, which is equivalent to just 3 mm thickness of ozone. Equivalent to just 3 mm thickness of ozone. If I remember correctly, one Dobson unit is, I think, 0.01 mm. That's why 300 DU is 3 mm thickness. It's more of your curiosity. So what is ozone layer? How is it formed? कहाँ मिलता है? Why not Arctic? Because Arctic is not as cold as Antarctic. Antarctic is more cold. More cold, the winds towards Antarctic are stronger. जो Dobson winds हैं, they are more strong towards Antarctic. And with global warming, okay, this is all getting disrupted. Yes, Arvind. Reduction of ozone is one of the reasons why we have global warming. Correct. That's why Antarctic is melting faster. Antarctic has the ozone hole, okay, and Antarctic will now receive more energy on the ice sheets, and Arctic starts melting more. But you know, the Montreal Protocol hai, it has addressed quite a bit of this. Ye bhi add kar lo. The Montreal Protocol, it's a global treaty. Montreal Protocol has fairly successfully addressed ozone depletion. Has fairly successfully addressed ozone depletion. Most countries are now phasing out all their ODS. Most countries have now phased out most of the ozone depleting substances, ODS. Yeah, this was among the first treaties we had. I think it goes back to 70s में जाएगा ये, 74, 73 में भूल जा रहा हूँ exactly है. It's older than all other climate treaties we have. The first one was Montreal, and Montreal is considered to be very successful for some reasons. Okay, and they want to replicate Montreal's success to climate change issues also. The Montreal Protocol. ठीक है, I think I have crossed our time limit. Okay. Yeah, that's good enough. We don't need more than this. Okay, we continue tomorrow. Again, 12 we start off. And all the new students, please make sure you make summaries of daily class notes. Older ones, okay, they are very smart, सबके बना रहे हैं. Okay, they are very competitive, very sincere. You also try to be sincere, the new ones. ठीक है? चलो, bye bye. So Jyoti is laughing and she knows why.